Hello guys, welcome to this channel. So today I want to discuss about rectifier circuits, and this discussion will be short and in a compact manner. So first of all, I want to discuss about why we need a rectifier circuit. Like, rectifier is a device which converts the sinusoidal AC voltage into either positive or negative pulsating DC, and then we attach a filter, and then we get the proper DC. So why we need this type of circuit? There is a dry cell and batteries can be used for this purpose. So why we need rectifier circuits? So first of all, no doubt the dry cells and batteries, they have the advantages of being portable and ripple free, but their voltages are low. They need a frequent replacement and are expensive in comparison to conventional DC power supplies. So nowadays, almost all electronic equipment include a circuit that converts AC supply into DC supply. The part of equipment that converts AC into DC is called the DC power supply. In general, at the input of the power supply, there is a power transformer. It is followed by a rectifier, a diode circuit actually, a smoothing filter, and then by a voltage regulator circuit. So this is what total blocks of the uh, rectifier circuits. First of all is a transformer, then rectifier, then filter, then voltage regulator. This is every DC power supply have this thing. Every the output of a DC power supply is used to provide a constant DC, because every nowadays your device will work in DC. So DC voltage across the load. Let us briefly outline the functions of each of the elements of the DC power supply. So first of all, what I say that there is a transformer. So transformer is used to step up or step down, usually step down the supply voltage as per need of the solid state electronic devices and circuits to be supplied by the DC power supply. And it can provide isolation from the supply line, an important safety consideration. It may be also include internal shielding of to prevent unwanted electrical noises and signal on the power line from getting into the power supply and possibly disturbing the load. And next I say a transformer, then rectifier. So rectifier, as I say, is a device which converts sinusoidal AC voltage into either positive or negative pulsating DC. So like PN junction diode, which conducts when forward biased and practically does not conduct when reverse biased, can be used for rectification. So diode can be used for rectification, and rectifier typically, and 4 darts a full wave rectifier, and like the full wave rectifiers have like center tap rectifier and a bridge rectifier. So we consider a bridge rectifier over a center tap full wave rectifier, because the extra center tap is needed, and whereas the bridge rectifier there is a no center tap is needed for the transformer. Anyway, so then we use filter for filtering the pulsating DC, and we get the proper DC. Like is so filter is a device which passes DC component to the load and blocks the AC component, so it's rectify the output actually. And then we put a voltage regulator, because the magnitude of the output DC voltage may vary with the variation of either the input AC voltage or the magnitude of load current. So at the output of a rectifier filter combination, a voltage regulator is required to provide the constant DC voltage in every circuit. Voltage regulator may be constructed from a like Zener diode or any discrete transistor or an integrated circuit like ICs. There's a lots of ICs like there's a constant 7905 is 5 volt constant. So there's a lot of its main function is to maintain a constant DC output voltage. However, it also rejects any AC ripple voltage that is not removed by the filter. The regulator may also include protective devices such as short circuit protection, current limiting, thermal shutdown, or overvoltage. So I think if people understand why we need a rectifier circuit, and nowadays every device used rectifier circuit for, our main lines are all AC, and so our every electronic device is operated in DC, so we need a rectifier circuit. And it's cheaper than in a dry cell or like batteries. Keep learning. Thanks for watching this video.